Hey guys, Mr. Backywork here. In this video, we're going to look at solving proportions using cross products. As we take a look at this first example here, it's a little bit different than some of the other proportions that we've looked at, specifically because as we look at the left-hand side, we have a variable in the denominator, and that makes solving this proportion a little bit trickier. So we're going to use something called cross products or cross multiplying. And what we're going to look at doing is we're going to take the denominator from one of the fractions and multiply it by the numerator from the other fraction, and then we'll do it vice versa. So what I'm going to do is I'm going to group up this x and this 6 together. We're crossing from the denominator up to the numerator, so this is why we're calling this a cross product. And if we take 6 and multiply it by x, we're going to get 6x. And then what I'm going to do is look at the other diagonal and multiply those pieces together. So we're going to be taking 8 times 15. And when we take 8 times 15, we get 120. Now there's an equal sign between these two fractions, so we need to keep the equal sign between these two pieces after we're done multiplying things together. Now what we need to do is look at our x variable, and right now it says 6 times x. So if we want to get rid of that multiplication by 6, what we're going to have to do is divide both sides by 6. So on the left-hand side, the times 6 and divided by 6 cancel each other out, leaving us with just a plain x equals. And then on the right-hand side, if we take 120 and divide it by 6, we get 20 as our x value. As we take a look at our next example here, we've got 2 over x minus 6 equals 3 over x. And we're going to use some cross multiplying, some cross products here. So I'm going to group up the 2 and the x first, and we're going to multiply those together. So 2 times x is 2x. Now on this one, the tricky part comes when we group up the x minus 6 with the 3. Because it's like the distributive property. When we take x minus 6 and multiply it by 3, we have to remember to multiply both pieces by the 3. So if I take the x times the 3, I get 3x. And if I take the minus 6 times the 3, I get minus 18. Now as we take a look at our equation, we've got variables on both sides. I'm going to move this 3x over so that we have our variables on one side and our numbers on the other side. This is a positive 3x, so I'm going to have to subtract 3x from the left-hand side. The positive 3x and the negative 3x cancel each other out. If I take 2x and subtract 3x, I'm going to get negative 1x equals the negative 18 that we have on the right-hand side. Now I need to get rid of the negative 1 that's in front of the x, and there's multiplication happening. It's negative 1 times x. So I'm going to divide both sides by negative 1 in order to get that to cancel out. So the left-hand side is just a plain x equals, and then on the right-hand side, if we take negative 18 and divide it by negative 1, that's going to turn into positive 18. In this example, we've got 4w over w minus 3 equals 2 over 3. We're going to do our cross multiplying or our cross products. So I'm going to look at the 4w times the 3. So 4w times 3 would give me 12w. Then I'm going to look at the other diagonal and multiply these together here. So we've got w minus 3 times 2. And again, we need to think about it like the distributive property. We need to take both the w and the minus 3 and multiply them both by the 2. So 2 times the w would give me 2w, and 2 times the minus 3 would give me minus 6. Now I've got variables on both sides, and we need to get them on the same side. So I'm looking at this 2w. It's a positive 2w, so to move that over to the other side, I'm going to subtract 2w from both sides. So on the right-hand side, the positive 2w and the negative 2w cancel each other out. On the left-hand side, 12w minus 2w is 10w, and this equals negative 6. Now I want to get the w alone, and right now it's 10 times w. So I'm going to divide both sides by 10 in order to cancel out that 10 in front of the w. So I get w equals negative 6 over 10. But anytime we're dealing with fractions, we always want to reduce down as much as possible. So I'm looking at the 6 and the 10 here, trying to find a number that we can divide nicely out of both of those. And the answer is going to be 2. We can divide 2 out of both 6 and 10. So we're going to get w equals, now negative 6 divided by 2 is negative 3, and on bottom 10 divided by 2 is 5. So we get a W value of negative 3/5. In our next example, we've got 3 over 4 equals n plus 5 over n minus 4. Now, when we set up our cross multiplying here, we're going to have to do distributing on both of these. So if I group up the 3 and the n minus 4, I have to take 3 times both pieces. So 3 times n is 3n, and then 3 times this minus 4 gives me minus 12. And then if I look at my other set of diagonal pieces, we've got the 4 times the n plus 5. So again, we're going to have to think about it like the distributive property. So 4 times n is 4n, and then 4 times this plus 5 is going to give me plus 20. Now we have variables and numbers on both sides. In this case, I always like to move the smaller of the two variables to try to avoid negative numbers if I can. So I'm going to move the 3n, and in order to move that 3n, I'm going to have to subtract 3n from both sides. So the positive 3n and the negative 3n cancel each other out. On the right-hand side, if I have 4n and I subtract 3n, I'm going to get 1n, but it's not necessary for me to put the 1 in front of the n. I can just write it as n. We still have the minus 12 on the left-hand side, and we still have the plus 20 on the right-hand side. Now, I want my variable to be alone, so I want to get rid of that plus 20, and in order to do that, I'm going to have to subtract 20 from both sides. So on the right-hand side, the plus 20 and the minus 20 cancel each other out, leaving us with just that n variable on the right-hand side. On the left-hand side, if we take negative 12 and subtract 20, we're going to get negative 32. So the n value is negative 32. Now our last example is a little bit of a word problem, and we're actually going to have to set up the proportion first before we go through and solve it. So we've got a blueprint for an office building, and the scale is 2 inches to 15 feet. And the completed scale model of the building is about 14.5 inches tall. And we want to figure out how tall the actual office building is going to be once it's built. So the first thing we're going to do is start building our proportion by looking at some ratios in here. So the first ratio that I see is this 2 inches being compared to 15 feet. So 2 inches on the scale model corresponds to 15 feet in the full life model. So I'm going to turn that into a fraction. I'm going to go 2 over 15. Notice the inches are on top and the feet are on bottom. So we're building our proportion here, so we need another fraction on the right-hand side of the equation. So on top, I put inches. The 2 was in inches. So I want to find another inches value that I can put on the top of this second fraction. And we were told that the scale model of the building is about 14.5 inches tall. So I'm going to put that 14.5 inches on the top of this fraction. Now we want to find the height of the actual building once it's completed, and that's going to be in feet. And we don't know that right now, so I'm just going to put an X on the bottom of this fraction. So here's the proportion that we're going to go through and solve using our cross multiplying. So the first thing that I'm going to look at is this diagonal where we've got the 2 and the x. 2 times x is 2x. Then we've got our equal sign in the middle. Now if we look at the other diagonal where we're taking 15 times 14.5, when we multiply those together, we get 217.5. Now I still need to get this x alone, and right now it's 2 times x. So in order to get rid of times 2, I'm going to divide both sides by 2. So the times 2 and the divided by 2 cancel each other out, leaving me with x equals. And then on the right-hand side, if I take 217.5 and divide it by 2, I get 108.75. Now this is a word problem, so we need to provide some sort of context for our answer, because this 108.75 really means something. And what we were talking about was the actual height of this office building, and we were measuring that in feet. So I'm going to say the height of the office building will be 108.75 feet. That's going to be it for this video. Thanks for watching.